All right, good morning, everyone. We are going to try a different video format today. I'm going to try my phone. We'll see if it's any better for you joining us from the video on YouTube. So this is the graph that was on that half sheet. If you're joining us on the video, it's linked in the day's agenda up above as our graphing warm-up. So this is our graph. Okay, this is from Menard's flyer. It looked something like, the whole thing said lumber prices have plummeted, now's the time to buy, something along those lines. Okay, so pros and cons. Let's start with the pros. Tell me something, and I want to hear from lots of people, not just one or two people, lots of people. Tell me something good about this graph. Elijah.
Lumber now is much more accessible considering that it's cheaper.
It's cheaper and more accessible. Okay. Okay. Lumber prices are cheaper, maybe more accessible. I don't know. Let's be careful not to draw conclusions based upon, that'd be like inference. Okay, that'd be an inference we could say. But we're not necessarily drawing conclusions. But yeah, lumber prices are cheaper. Okay. Tell me about the graph itself. Yeah.
Through April through June, their prices are going up and they got more buyers.
Okay, this again, we want to talk about, we're not drawing conclusions about data. I'm talking about the physical graph. What is good about this graph and what is not as good about the graph. But yes, the trends do trend upwards, then it does dip. That is true. But let's talk about the graph itself. Yeah.
May is high, but September is low and July is dropping.
Again, I'm not asking you to interpret the graph. What is good about this graph? And what is
lumber prices are dropping?
That's not what's good about it. Again, you guys are interpreting the graph. No, hang on. I'm asking very specifically, what makes that graph a good graph? Maybe I worded this question poorly. What makes that graph a good graph? Yes.
The x-axis is labeled.
We have our x-axis labeled. Good. Okay, that's what I'm looking for. Attributes that makes this graph a good graph. Okay. And let's continue on that trend. What makes this graph a good graph?
Or the graphing line.
There's a line. Yeah, there's a line that shows trends, right? Okay, they do show a line that has a trend to it. Okay, anything else we want to talk about positives? We can jump back to positives if we want in a minute too. Yeah.
It shows it doesn't show points, so that might be a negative.
It doesn't show what?
It doesn't show exact points. It just shows up and down and left to right.
Okay. Okay, so any other positive before we switch to maybe the negatives? Okay, so what was said was like there's not a lot of, the points don't necessarily show negatives. Yeah.
There isn't prices in the Y variable.
Right. On the Y variable, it doesn't say prices. Now, when you say prices, are you saying numbers?
Yeah, like the cost of the lumber.
Right, there's no scale here, right? That's kind of what we're saying. There's no data, there's no points. I'm going to say, do we even know for sure that this is price on the Y-axis? I'm assuming, much like you are, that since the heading said lumber prices have plummeted, I would also assume, I don't know if I could draw the conclusion, but I would assume that was intended to be price.
It could be stock prices or stock or whatever.
But we don't necessarily know because they didn't label it, okay? So one thing a good graph has is all their axes, both X and Y, need to be labeled. That's a trend of a characteristic of a good graph. Okay, so it's missing a title, it's missing numbers. Anything else?
It doesn't have a table, but normally with the graph, there's normally.
But this
a
is
table.
a table is a separate way to portray information, and we use our data table to often build a graph. So while that's not necessarily necessary for a graph. Anything else we want to point out about negatives? Yeah.
It only shows the past 9 months.
Yeah, it does. It only shows it. You know, it doesn't show a super long, you know, we're talking January to September. Where were they 2 years ago? You know, were they here? Like, let's continue this graph. Pretend it goes, were they here 2 years ago? So while they are lower than January, they're still like much higher. They're higher than September. Maybe, okay? Maybe it depends upon what we're trying to study. Okay? Anything else negative you want to address? I'm going to do that. So if we were to kind of do this, if I were to kind of draw a dotted line at the lowest point, which according to my graph is September, and I were to draw a kind of dashed line at the highest peak, which is right around May or June. If we were going to draw conclusions from this data, which I didn't, that's not what I asked you, but if we were going to draw a conclusion, is it fair to say prices, lumber prices are at the lowest they've been since January? Is that a fair conclusion?
Yeah.
Yeah, right? This is every data point until now, from today since January, it's lower than. Okay? How much lower are the prices today than they were in May or June? Again, one of the negative things, right? There's no scale, no axis. And then one of the reasons I'm using this graph is its intentions are, I believe, meant to be helpful, especially for Menards, saying, hey, you've heard about all those high lumber prices over the last X many months. Prices are coming down. Now's the time to build that project you've been wanting to, right? That's kind of what they're hoping for. Because what are they in the business of? Selling product, and they want to sell their product. So if you have consumers that say, ooh, I'm not going to build that shed because prices are really high right now, this might give them some confidence, right? However,
Could that be skewed?
It could be not the all-time low.
okay, so let's say a good graph should have a title of what we're looking at. This is one thing that this graph didn't have, so I added a title. Dollars, wait, that doesn't make sense. Dollars of 8 foot 4, this should be amount, so I'm just abbreviating, for an 8 foot 2x4. Okay, so we're saying it's a 2x4 that's 8 foot long. Now, in the ad, it talks like, I don't remember if it talks about pressure treated in particular. It does, but let's just call it 2x4s. What if we actually added a scale to this? What if the price right now, I am completely making up this number, just for the record, I am completely making up this number. So right now, this 8 foot 2x4 is $8. I believe it would be higher than that, but it doesn't matter for the sake of this. We're just going to say it's $8. Is it possible that back in May or June that was the price of a 2x4? It could be, right? Is $8.02 higher than $8? Yes, which would then also mean that here it was right around $8.01. Again, completely made up numbers. The reason I'm bringing this graph up is you as a citizen and a science student needs to be mindful of graphs like this, because a graph could be intended to help mislead you or try to prevent like a, I don't know, false sense of security on something, right?
The data can be manipulated on a graph to, if you have an agenda, in this case, Menard's agenda is, hey, we want to sell some lumber, right? Now's the time to buy.
Prices
Look
are
at the
low.
depth.
Whoa!
You go in there all fired up, holy cow, it's the cheapest it's been in months and months and months. It's 2 cents.
Okay. Is it cheaper? Did they fake data? Let's assume good intentions. No, they didn't fake the data. But the idea is they portrayed the data in a slightly misleading way. perhaps, again, this is just something I'm making up, maybe Menards is, maybe it was $8 today and it was 15, maybe, right? But we don't know. And that's the point we're trying to make, is we don't know what this represents because it doesn't tell us.
Label.
So we need to have labels on our both x-axis, the y-axis, and our overall graph so we know what we're even looking at. Now, if we really quickly say, hey, this is dollars, and then this is months. Oops, I don't know why I put it there. Okay, there is our months. You can't see dollars. There's our dollars on our y-axis. If we talk about independent variables and dependent variables, there is a trend here as well that we want to make sure we're clear on. When we graph the data, our independent variables and our dependent variables go in a very specific spot. It was in your notes, it's in your guided notes. We talked about what goes on what. I change the independent variable. Now this one gets a little tricky. If I am graphing months versus dollars, or dollars versus month, I should be careful how I say that. What am I physically changing with my data collection? What am I changing? Am I changing the dollars of the 2x4s? Or am I changing the date at which I'm collecting the data? This one gets a little kind of tricky, but what am I changing? Am I changing the dollar price?
No, Menards is.
Okay, so what am I changing? I'm changing the date, right? I'm changing the date in which I collected the data. In this case, what month? Okay, I am changing that. So my x-axis gets the independent variable. What am I measuring? Was my dependent variable? I'm measuring the price. Same thing in our lab. What are you going to change? You're changing the amount of aspirin in your bag. That's your independent variable. What are we measuring? We're going to measure how many seeds germinated. And we're going to use that data, and we're going to graph that data. Then we can draw some conclusions. Okay, good title. Labeled axis, scaled axis. Okay, we want to make sure we scale this. Anything else before that we forget? So those are some things we want to keep in mind. In just a moment, we have a couple things that we're going to work through today. I'll put that back on the screen. Today, in class, we did use that warm-up to introduce some concepts of what graphing data should be. Remember that your radish seed lab report through the procedures were due last night. Okay? Everything should be typed in there, your name, title, research question, hypothesis, I believe next was materials, followed by procedures. From name through, which means including, procedures should have been completed, and that Google Doc gets sent to Canvas. That was due last night. Then what we're going to do right now is we're going to collect some radish seed data. We're going to give you some time to work on that POGIL activity called experimental data. There's some housekeeping things that if you haven't gotten 100% on your safety quiz yet, that's something you need to take care of. One thing I am going to start doing here, hopefully I get to it tonight or sometime this afternoon, if you do not have 100% on your safety quiz, I'm going to start assigning you to ELT until you get it done. If you do not have your Radiseed lab through procedures turned in, I'm going to start assigning you to ELT. Now, I'm not going to start making those assignments till tomorrow. So if you don't have that stuff done, realize that that will soon be happening. Now, you are more than welcome, and maybe I haven't made that clear, you are more than welcome to come into this classroom and work on biology during ELT, even if I don't assign you. If you want to come in and say, hey, I need some help with biology, absolutely, come on in. I want to make sure that's clear. These are some things that I'm going to make sure we get taken care of in the next day or two. And I'm going to start making those ELT assignments after 10th period. Okay? When we collect our data today, you have a bag, hopefully labeled, and you know what's in each bag, that has your radish seeds folded into a piece of paper towel. What tends to work the best in terms of minimal mess is if you take that plastic bag, you open it up, it might smell for the record, and you pull that wet paper towel out and you set the wet paper towel right on top of that plastic bag. You have aspirin water in that bag, and if you put it on your bag, it helps eliminate some of the mess that we get on the table. We're still gonna do a quick wipe down of the table to try to get rid of any of that mess, but you're gonna take it, you're gonna gently unfold the paper towel. Then you need to very carefully look at each and every seed to see if it has germinated. Germination means the seed has started to grow. It has sprouted would be another word for it. If it is cracked and has a little tiny root sticking out, it counts, it germinated. If it doesn't have any, it did not germinate. Okay? If you need some little tweezers to kind of help sort, start within your lab station. The upper right-hand drawer may have one in there. If not, check the upper left, the top two drawers, I guess. Check the top two, and I'll go dig a couple out. Some people like to use tweezers because you can kind of grab and sort a little bit.
Especially if they get stuck together a little bit.
Yeah.
If you're not sure on if it germinated or not, I just can't quite tell, then just raise your hand. We'll make a call for you if you don't want to.
Make sure you record your data. There's a spot in your lab report for how many total seeds did you have in your bag, how many germinated, how many didn't germinate. Now your data table, I just thought of this, might only have a spot for 3 bags, but some of you did use 4 bags. So if you can't figure out how to add that next line, let us know and we'll try to help you figure that out. I just thought of that.
And pay attention to what bag you are recording where. So not only are you getting the data from your bags onto your table, but if it's the bag with no aspirin or 1 aspirin or whatever, make sure you're getting that put into the right spot, okay? So pay attention. Hopefully you had your bags labeled. You had them label it for a reason so you know which bag goes where.
So, collect data, make sure you record that data. A good graph, we talked about some attributes of a good graph. One of the things that we're going to ask you to do is make sure you graph your data. There's a couple different ways you can graph your data. We will provide some graph paper. If you want to neatly hand draw your graph, I would use a bar graph for the record. I do a bar graph. If you want to neatly draw your graph, make sure you have all your things labeled, take a picture and insert into your lab report. That's fine. If some of you say, hey, I know how to make an electronic version of this using XYZ, go for it. We're not going to teach you that today on how to graph this data electronically. So we're going to say a picture of your bar graph is perfectly acceptable, neatly drawn. One thing we forgot to mention about a graph is it should take up some space. Okay, try to scale it such that it fills the paper that you have or most of the paper you have. Because if you have a bar graph that's only like this big on a piece of paper, it's really, really hard to see, not very user-friendly. So make sure we fill the space that will be provided. It's probably going to be a half sheet of bar graph paper is what we'll cut off and we'll put next year. We'll put on a back table for you.
Easy way to make your lab report look even more impressive.
Okay, so collect data, These are the kind of the next things I'd say we want to make sure we're working on. If you get that stuff finished, then start looking at your conclusions in your analysis portion. There's some prompts that we have for you to answer in your conclusion statement. There's no place for you to turn in your final completed Radisseed Lab report yet. That will be an S2 standard. It's coming, not there yet. Okay, but we got to make sure we get our data collected today, and we'll get some graph paper out that if you want to use that, and we'll get some colored pencils out so you can kind of color code, make a key if needed, right? So we're going to give you some time to work on that. If you need some help saying, did this sprout, did this not germinate, let us know, and we'll make sure we do our best to answer those questions for you.